question 6, you need to be very systematic when you are trying to solve this question. So before looking at the distractor, okay, let's break down the motion of the ball being thrown into the air from rest and eventually fall into the ground. So what I have here is that I basically you have to imagine that I'm taking photos when the ball is being thrown up. So when at time equals 0, I take a photo. At time equals to 1, I take a photo. Time equals to 2, I take a photo, and so on and so forth. So now that I will have a time frame, like for example, like the ball is being freeze like that. Okay, so when time equals to 0, I'm just about to throw the ball. So therefore, this arrow here represents the velocity factor. Velocity is a factor quantity, right? It has a direction. So the moment when I'm just about to throw, the velocity will be highest because I just applied a force onto the ball so that it goes up. Okay, so this will give me the maximum velocity. Okay, but as the ball goes up, okay, because we are doing this thing on Earth, right? So on Earth, the gravitational acceleration is always pulling the ball down. So because of that, the velocity must have gone down. Okay, by, let's say if this is 100 meters per second. Okay, because gravitational acceleration is minus 10 meters per second square, meaning that every 1 second, my speed will be slowed down by 10 meters per second. So if I have 100 meters per second here, after 1 second, I will get 90. After another second, I will get 80. After another second, I will get 60. So on and so forth until my velocity will be eventually become 0 because acceleration is the opposite direction. So this is my highest point when velocity is equal to 0. Meaning that when the ball is traveling up, okay, when this part here, right, okay, the ball is moving up. So when the ball is moving up, my velocity here will be decreasing. From 100 meters per second, 90 meters per second, 70 meters per second, 60 meters per second, all the way until 0, where it reaches the highest point. And as it goes down, so down here is when the ball starts to go down. This is moving down. Okay, when it is moving down, because the gravitational acceleration is pulling down, it will basically accelerate down. So you can see that your velocity factor will getting bigger and bigger. So as the ball moves down, the velocity here will be increasing. Yeah. Okay, so once you understand this relationship, okay, look at the option. The direction of motion is going down. Okay, so let's look at these two first. It's going down. So when the motion is going down, my velocity will be increasing. So this one, you know that A is wrong, right? Okay, why is it wrong? Because KE is half equals to mv square, right? So if my velocity is increasing, my KE must be increasing as well. And then you look at the potential energy. When it is moving down, the height will be decreasing, right? So your PE, oops, I just realized I write the wrong thing. PE will be mgh. And because if it is moving down, h will be decreasing, right, as it go nearer to the ground. So therefore, it won't be increased, it will be decreased. So therefore, you already know that the option B is correct. Now, just for completeness sake, let us look at these two options when the motion is going up. So when the motion is going up, you realize that the velocity is decreasing. And if the velocity is decreasing, your KE cannot be increasing, right? So therefore, C and D is wrong. Okay, question 7 is talking about heat transfer. So if you want to survive the cold, basically what you are going to do is that you want to lose heat very, very slowly. And it also means that the bear is actually losing heat, and therefore the word to be used here must be emitting. Absorbing will be wrong because the polar bear is warmer than the surrounding. Reflecting is also wrong, okay, because again the polar bear is warmer than the surrounding. So therefore, if you look at the cartoon I draw here, the bear will be higher temperature, surrounding is lower. So the heat transfer will be from the bear to the surrounding. So the keyword to be used is emitting. It is not absorbing, it is not reflecting. So let's carry on looking at all the options. Okay, if you look at let's look at option B first. White surface a good absorber, like I said. Okay, anyway, white surface are poor absorber, and in this context absorbing is not correct because the bear is emitting. And if you look at C, white surface are poor absorber. Okay, white surface are poor absorber, that is correct, but in this context it is not absorbing. Okay, the polar bear is not absorbing, therefore C is wrong. Okay, D, white surface enable the polar bear to reflect heat. Like I say again, the polar bear is emitting heat. Okay, the environment is cooler than the bear, so therefore the bear will not reflect the heat away. So if you look at the last option, option A, white surface are poor emitter, which is correct, it is poor, and it fits into our problem context. Okay, and it serves the correct purpose, so your option A is correct. Okay, now is what? Question 8. Okay, question 8, evaporation cause cooling effect, and basically cooling means that you are losing energy. Okay, so if you look at this, there are less liquid molecules in the leftover liquid, so the cooling effect, okay, has nothing to do with having less molecule, okay, because cooling is related to energy, not the mass. Mass is the amount of molecules in a body, right? Amount of particle in a body. And cooling has nothing to do with mass. It has only something to do with energy. So A is basically wrong. Then B, there is more heat energy entering. Okay, again, if you have energy entering the liquid, you won't be losing energy, you'll be gaining, right? So therefore B is wrong. C, okay, we'll talk about C later because C is the correct answer. D, the liquid has less potential energy and more kinetic energy. Now, what they are referring here is the internal potential energy. And when you change the state, okay, let's not talk about internal potential energy. Let's just talk about internal kinetic energy. Internal kinetic energy is always related to the temperature. The more kinetic energy you have, the higher the temperature, and vice versa. So therefore, if you are having a cooling effect, you will definitely not have more kinetic energy. You should have lower kinetic energy. Okay, and this part basically doesn't make sense. Okay, if you look at C, the average kinetic energy of the leftover molecule is now less. So yes, kinetic energy implies is directly related to temperature, and if you have less kinetic energy, you would have less temperature and therefore a cooling effect. So therefore C is correct. Okay, question 9. Question 9, you need to be careful. Okay, the formula to be used is V equals to F lambda because we are talking about wave, and that's why they give you the wavelength and they're asking you for the period. So that's why you need to use this V equals F lambda. Now remember that whenever you are using the formula, you must change everything to the SI unit. So the SI unit here is meter per second, but in the question they gave you as kilometer per hour. So please do the conversion here. 18 kilometer equals to 18,000 meter, and 1 hour is 3,600 seconds. Use a calculator, change it into decimal. If not, just directly substitute here. So if you plug everything into this formula, since you are given wavelength, you will be able to find the frequency as 2.5 Hertz. And you know that frequency is equals to 1 over T, so use this answer and substitute into this. Eventually you will be able to find the period, which is 0.4, option B. Okay, question 10. Question 10, basically you are comparing things with visible light. You are comparing radio wave with visible light. So what I've drawn here is the EM spectrum. The visible light is in the center, on the right is the gamma ray, on the left is radio wave. So radio wave basically is having higher wavelength and lower frequency, but all the wave in the EM spectrum are actually having the same speed. So therefore, if you look at B, the speed is different, you can already cross it out. Okay, and then when you look at the frequency, radio wave will have a lower frequency than your visible light. So lower wavelength. Did I say lower frequency? Okay, yeah, lower frequency. Lower frequency. Lower frequency. Yep. So, yeah, this is wrong. Yeah. Hey, wait. The visible light will have a higher. Oh, yeah. Okay, I'm comparing visible light with radio wave. So, visible light will have a higher, because visible light is here. So, visible light will have a higher frequency than your radio wave. Yeah, so C is correct. Yep. Okay,